only have one hat there. All right, chloramine reduction. So activated carbon can take chloramines out of the water, but it takes time. It takes contact time to do that. So I would have to flow the water through a block like this really slow in order to get the chloramine breakdown and to get it removed. Ineffectively so. It's not efficient. It wouldn't be worth doing. So instead of doing it through a regular block like that, what I can do with the carbon, the activated carbon, is I can catalyze it. So I can add a catalyst to the carbon to make it work quicker. That's what a catalyst is. It makes things work quicker. There's a number, anytime you see catalytic carbon or catalytic medias or anything like that, the catalyst means that it's just something's been done to it to make it work more effectively. For the Chlor Plus, what we've done is we've surface treated the carbon so that there's more sites. There's more reduction sites so that the surface area is amped up for the chloramine reduction. So that'll still flow the same amount of water that you would get through it for a similar carbon block for chlorine reduction, and then it'll be able to take chloramines out of the water. Your customers, and I'm guessing based on what you said, Rusty, your customers are becoming more and more and more aware that there are chloramines in the water versus chlorine. They need to understand that it takes a different filter to take chloramines out of the water than a regular activated carbon filter. So because if they're using that for pretreatment for things protecting ROs or doing things that they're not going to get the performance that they're expecting that they used to get for chlorine reduction. So Chlor Plus cartridges, especially if you know you've got chloramines in the water around here, we should be promoting that more and more, that takes a special cartridge to do that.
They sell very well in Houston because Houston's levels are insane sometimes.
Do chloramines and chlorine have the same effect on an RO membrane?
Yes. Yeah. Initially, the idea.
And ion exchange resin?
Yes. I don't know that it's the same how it works and what it does, but they'll both break down the bonds, the cross-link bonds. I believe it might be in a different way that it happens, because the initial. I have a really cool picture.
You should touch on cross-linking too when you.
All right, I can do that.
Well, because with the chloramines, if you go to like a hardware store and you get like a chloramine-resistant toilet flapper and a regular toilet flapper, they're massively different. And so I feel like chloramines have to be eating more of the plastic than the chlorine. Like
I think that the way that they attack those materials is different. I think the results are
it's
similar.
just a hardware store. Like it's just like here's your chloramine one, here's your regular one. So I don't think the Home Depot's.
And what is the flapper difference going to do?
No, I'm just saying it's like it eats the plastic more. Like the chloramine resistant toilet flapper is much bigger because it's
like
chloramine.
bigger?
Yeah.
Or, okay.
It's a stronger rubber, so the ammonia's not eating it.
When we make chloramine resistant seals for valves and stuff, we'll still use EPDM, but it's a different durometer, it's a different material.
So it's like a 10-ply tire versus like a 4-ply tire.
Sure. Yeah, it's exactly like that.
Yeah.
It just changes the the rigidity of the rubber changes so that it stands up better one versus the other.
Cool.
All right.
Thank you.
Yeah, you're welcome. You already got your mouse pad, man.
Oh,
all right, okay. Well, keep it up. All right, so I'm going to flash through this real quick, just because give you an eye line on some of the things that are available. Again, benefit with Pentair is breadth of product line. So you have everything that you see there are some of the things that we talked about the range of cartridges. In addition to carbon cartridges and sediment cartridges, which you can see here, specialty cartridges like for softening or for deionization, and that's making pure water, pure H2O. H2O on its own, pure H2O on its own doesn't occur naturally in the world.
It's toxic. No, pure H2O will kill you.
Did you not read the book they had us read when we started?
You're not making it for consumable water, though.
I know. I'm saying it's like the book. They do it for like washing computer boards.
Yes.
And so if you drink the water, it will kill you.
Okay. So DI cartridges will make pure H2O.
Thank you.
That you're not supposed to drink.
That's
But will it really make
Some of the
chlor-
things, so if I'm making, so think about this. Water is a primary ingredient in a ton of different stuff, right? If I want to make the best liquid soap, and one of my primary ingredients is water, I want to start with the most pure water that I can, so when I add the other stuff into it, I have a product that is the highest level of final result. I know I can control my result because I know that the thing I start with that I call water is DI water, H2O. So it's not making it for drinking water, it's making it for production of liquid soaps. Labs use it for substrates to grow cultures in and stuff. Starting points. I'm making pure H2O, brought up about integrated circuits, production of integrated circuits. Water on its own does not conduct electricity. Pure H2O does not conduct electricity. In fact, it's a very, very good insulator. It's the stuff that is dissolved in the water, the TDS, that creates the free electrons that conduct electricity. Does that make sense?
Yeah, so whenever you were a kid and it started raining while you were in the pool, and your family was like, get out, so you don't get electrocuted, that's because of the chlorine inside of the pool?
Right. It's all the ions that are dissolved in the water
Technically, if it
that
was
are going to
like
conduct electricity.
Straight H2O and you were swimming in it, you wouldn't have to worry about getting electrocuted?
No, you wouldn't have to worry.
But
You
you
would
know
have to
it's
worry
not
about
like
stuff
the
getting
regular.
extracted out of your skin because that H2O, the pure H2O, would be.
So for your standard like homeowner, like your regular consumer, they're not going to want straight H2O?
It will kill you.
No.
They'll say they want it, they just don't know.
So okay.
So
That's my question. So
for
if somebody
drinking
comes
water
in,
application, you're kind of in that 96 to 98% range, and there's still some TDS in the water. It's not pure water.
so like Bobby Boucher is totally wrong then.
Say cartridge. So these are housings. You have specialty cartridges that also do like polyphosphate feeds, calcite feeds, things of that nature. We have housings that we can do. So we have big blue housings, we have standard housings, we have slimline housings for fitting all kinds of manner of different flows and cartridge sizes. We also get into the E series, so that's more of an industrial. Now this line has been limited down quite a bit in the last year, 18 months. Very restricted down, but we still do have stainless steel housings of this manner and carbon steel housings called the E series, so we can get into bag filters and so forth for really high flow demands. The breadth of the product line is the strength. And I'm just going through here to let you see, get a look for that. All of this information is in this presentation, so it is stuff that we can hand down to you for reference material.
That's what you were referring to from the clear housing?
We
Yeah.
do not sell clear acrylic housing.
Why not?
Issues with
The
perception of.
the sump replacement rate.
Okay. There's definitely a more limited lifespan on the acrylic than there is on a standard polypropylene housing sump.
More expensive.
And then the other is, when somebody wants you out there every week to change filters,
Okay.
that's a little,
Challenge?
It's a little ridiculous.
High temperature, we have high temperature housings with stainless steel as well as the high temperature poly. The high temp poly goes up to 150 degrees. All natural, that's more of that's for like the institutional. So this is a virgin material that the reason that it's used in certain places is because it has no leachable components in it. It's not going to comprise, it has no danger of blending itself to anything in the water.
Prop 65. What would that, would it get the sticker or no sticker?
I don't think that I think a lot of our material, so Prop 65 it has to do with California and what
Yeah.
they're looking for as far as leachables and stuff
Yeah.
into the water, and I believe it has to do with volatile organics being leached into
Yeah.
the water. It's not that, Prop 65 isn't a challenge for the specific product group, it's a challenge to get that Prop 65 rating is a cost, an additional cost. Does the additional cost in getting that label on justify doing it if it's just going to be a
Right, but
limited
so for
number?
the natural one, wouldn't that would be?
Yeah, I would imagine it would be the case, yeah. Here's your pleated lines, and then all of the information about the pleated series, string wound cartridges, and then all manner of poly melt blown cartridges and so forth. So again, this is just for your information. We also make dual gradients, so bigger, so outside surface